OSIRIS-REx, NASA's pioneering mission, touched down on asteroid Bennu in 2020, scooping a sample. It is now coming back to Earth and scientists are really excited about what they might discover. I am Dr. Alfredo Carpinetti, IFL Science senior science writer, and I spoke to some of those scientists about what we might find out from that sample. Join us in this fascinating journey to the potential and intriguing mysteries of not just Bennu, but the whole solar system. And you might also find out how legendary guitarist Sir Brian May got involved into this mission.
I am Brother Bob Mackie. I am the curator of meteorites at the Vatican Observatory, which means I take care of the Vatican meteorite collection of 1,200 specimens. I think I'm very interested in the arrival of the asteroid Bennu and or the specimens from the asteroid Bennu. This will be the largest specimen we've received from an asteroid to date. We don't yet know how much there is, but we hope it's a lot. And my interest in particular is physical properties, density and porosity. So density is the mass divided by volume, and porosity is how much pore space. And we have a general idea of those properties for the asteroid as a whole from when OSIRIS-REx visited. When we can compare it with the actual specimens we have in the laboratory, we can get some better idea of the overall structure of the asteroid.
I'm Dante Lauretta. I'm the principal investigator of the OSIRIS-REx mission, which is a NASA-funded program to send a spacecraft to a near-Earth asteroid named Bennu and collect a sample to bring back to our planet for analysis in our laboratories. We launched in 2016, and I think that's when I was first introduced to Brian by a mutual colleague. We're both co-signers for an organization called Asteroid Day, which is a United Nations sanctioned event to raise awareness of asteroid science, the asteroid impact hazard. I thought, hey, cool, I'm talking to a childhood hero. I was a huge fan of Brian's music when I was a kid, still am today. And I thought it was actually fake at the beginning. I thought I was being, punked or whatever, that this couldn't be really the real Brian May. And I said, oh, thanks for the warm wishes and the successful journey. And then sure enough, as soon as we started returning data from the mission of images of asteroid Bennu, I got another message from Brian. He says, hey, we see what you're putting out there on the internet. What do you think of a stereo view? And it really changed my whole perspective of the data. I was like, all of a sudden, a new dimension opened up. We were looking at Bennu in 3D. I knew the value of the science was enormous. So I said, we're really struggling, Brian, with our site selection. We had to find a safe location to collect the sample. And there was nothing that was obvious when we first arrived there. So I said, would you mind giving us a 3D view of these coordinates? And I think the next day it was in my inbox. And he sent me a really nice message saying how much it meant to him to be part of a program like this and that he really wanted to help.
We assembled stereo images, 3D images from all kinds of missions. And it was a kind of dream to me because, as I say, we're on the outside. I thought, wouldn't it be great to actually collaborate with some of these guys here, the real scientists? And suddenly I have this real scientist who's sending me stuff to do, and it becomes it's kind of like a job because it was a lot of hours to put in, but it's joy. It's just such a joy to work on these images, and they're a bit rough to start with. It's hard. You have to align them up. You have a lot of problems with shadows, which I have to fix, and it kind of can give you headaches. But once you get it fixed, it's beautiful, and you can enjoy looking at the surface of this planet as if you were there.
My name's Sarah Russell and I work on the meteorite collection at the Natural History Museum. So we've got one of the world's best collections of meteorites, and I use it to learn about how our solar system formed and evolved. So using meteorites that formed right at the beginning of the solar system's history. My background is in geology, and your very first lecture as a geologist, you're told you have to know where your sample came from. You have to do field work. You have to know exactly where your sample, how it fits into the landscape, what the rocks around it are like. And if you study meteorites like me, unfortunately, that's a privilege that we don't normally have. So a meteorite is any natural extraterrestrial object that falls to the Earth, and it falls without any context. We've got no idea where it came from.
One of my favorite moments from the mission was I had a site selection board, right? A technical panel that was looking at the spacecraft and the surface and the science and everything. Could we get down and collect the material? And Brian had been working with Claudia producing these stereo images of potential sites. I think up to 50 you had actually processed at the time. And Brian sent a case of his OWL stereo viewers to the team. And I opened up the box, these beautiful red devices that you can put your cell phone on, and you can see the stereo images right on there. And I passed them around and I said, we're just gonna flip through. And all of a sudden it became apparent the material that we could collect was in these really small bowl-shaped craters, which the spacecraft team was not excited about sending the spacecraft into. But immediately I was like, we have to figure out how to get into one of these craters. And it was the stereo images that was my wow moment, although it was more like a, oh no, kind of moment. But it was like, it became clear the challenge that we were facing.
From the work over the last decades, we know that most meteorites come from asteroids, and a few come from the moon and a few come from Mars. We don't know very much about what type of asteroids they come from, how big they were, whereabouts in the solar system they originated from. But to kind of go the next step in meteorite research, we really need to have that context. So both the geological context, kind of knowing what rocks were around the sample that we've got, but also the astronomical context, knowing whereabouts in the solar system the sample came from. And so space missions like Bennu are like field work for meteoricists. They're like the next step that will enable us to learn more about these rocks, really important rocks, and what they can tell us about the beginning of the solar system.
We are very excited about this mission. We cannot wait to find out what kind of science will come out of this sample. Check back in a few days to find out how the sample retrieval went.